This next section, we're going to look at our next macronutrient, which are lipids. And lipids are the same thing as fats. As a review, the macronutrients are the three components that give us calories in our diet: fats, carbs, and proteins. You also can get calories from alcohol, but vitamins and minerals do not provide us with any calories. So what do lipids do for us? What is their function, or why do we need them? Lipid is the chemical term for fat, and lipids are responsible in our foods for contributing texture, taste, mouthfeel, flavor, and aroma. When you walk through or walk by a bakery and you smell those beautiful cinnamon rolls cooking, what you're smelling is the fat in the cinnamon rolls. That's the aroma, and it contributes a lot of flavor. And we as humans also really like the mouthfeel that high-fat foods give us. They taste good and feel good on our tongues. In your body, fat also plays a role as well. The fat in your body is responsible for padding your body's organs, insulating your body, and fats also play a role in the sense that they are a part of every single cell membrane in your body. Fats and oils give us 9 calories per gram. We say that they are the most energy dense of the macronutrients, because carbs and proteins only give you 4 calories per gram. But in the same amount of fat, you get 9 calories, which is more than 2 times as much. So it's the most energy dense because it contributes the most calories per gram. In the typical US diet, about 33% of the calories come from fat. The notion is that a high-fat diet is also usually a very high-calorie diet. And some people can lose weight when they reduce the fat in their diet because they are reducing the amount of calories in their diet. There are 3 primary classifications of lipids, and we're going to spend the most of the time looking at the triglycerides. Triglycerides make up 95% of the dietary fat that we eat. It's the major form of lipid in the foods, as well as the type of lipid in our bodies. We also have phospholipids, which allow water and fats to mix in the watery environment of your intestinal tract. And phospholipids have a hydrophilic phosphate head and a hydrophobic fat-soluble tail. I'll show you a picture of that in a moment. The third type of fat that we're going to look at are sterols. And sterols are things that you're probably familiar with, for example, cholesterol. Vitamin D is also a sterol, as are sex hormones, and cortisol, which is a stress hormone. So the primary type of fat that we're concerned about are triglycerides. Triglycerides, as I said, make up 95% of the fat in your food and in your body. And if you break down the word triglyceride, it gives you an example of the chemical structure. You've got a glycerol backbone, which is the glyceride part, and then you've got 3 different fatty acids attached to it. So here's your glycerol backbone, 1, 2, 3 fatty acids, tri standing for 3. So a triglyceride is comprised of a glycerol backbone with 3 different fatty acids. Perhaps you've heard of fatty acids that are either saturated or unsaturated. We say that a saturated fatty acid is when each carbon atom is attached to as many hydrogen atoms as possible so that no double bonds form. Okay? There's absolutely no vacancy. You can see it from this saturated fatty acid, which is palmitic acid, that there are no carbon-carbon double bonds. An example of a saturated fat is the fat that you see on the outside of meat. And we say that saturated fatty acids are solid at room temperature. So you can remember S for solid and S for saturated. Unsaturated fatty acids do have carbon-carbon double bonds. A monounsaturated fatty acid is one that contains 1 carbon-carbon double bond. So an example of a monounsaturated fatty acid is shown here. This one is oleic acid. You can see the carbon-carbon double bond is annotated in orange. A polyunsaturated fatty acid is one that has 2 or more points of unsaturation, or in other words, 2 or more carbon-carbon double bonds. There are 2 polyunsaturated fatty acids shown here, linoleic acid and alpha-linolenic acid. Perhaps you've heard of omega-3 and omega-6 fatty acids. In case you're curious, the way you can tell if a fatty acid is an omega-3, 6, 9, etc. is by counting from the methyl end, and that's the end over here, how many carbons you run into before you meet the first carbon-carbon double bond. In the example of this alpha-linolenic acid, you've got carbon number 1, carbon number 2, and carbon number 3. At carbon number 3, you see the first carbon-carbon double bond forming, making that an omega-3 unsaturated fatty acid. In the one in the middle here, we've got an omega-6 because 1, 2, 3, 4, 5, 6 carbons into the fatty acid from the methyl end is where you encounter the first carbon-carbon double bond. Oils have varying degrees of saturated fatty acids or unsaturated fatty acids. In this slide, you're seeing in red, it indicates what percentage of the fatty acid profile is made up of saturated fatty acids. So if we start from the bottom, you see things like butter and coconut oil. Coconut oil is 91% of the fatty acids in that oil are saturated fatty acids. As you go up, you see things at the top like canola, safflower, olive oil. These have 15% or less of their fatty acids coming from saturated fatty acids. In this slide, the blue indicates polyunsaturated fats, as does the orange. And then the yellow makes up the monounsaturated fats. So you sometimes hear that oils such as canola oil and olive oil are called heart-healthy oils. And that's because the majority of their fats are coming from monounsaturated fatty acids. When we get into things like what we call the tropical oils, things like palm oil and coconut oil, they have a very high percentage of their fats coming from saturated fatty acids. Saturated fatty acids, they raise our bad cholesterol and they raise the total cholesterol. And we'll go into more detail with this when we look at cardiovascular disease. The types of foods that you eat have a variety of fats in them. You don't eat a food that's 100% monounsaturated or 100% saturated fatty acid. But there are foods that have a majority of their fatty acids coming from either monounsaturated, polyunsaturated, or saturated fatty acids. So if you look at the left-hand side of the slide, you see a list of what we call some of the heart-healthy fats, those that contain primarily monounsaturated fatty acids. That's things like avocados, olives, sesame seeds, certain types of nuts, and then those heart-healthy oils like canola, olive, peanut, and sesame oil. On the other side here, we see the saturated fatty acids, the ones that tend to be less heart-healthy or that elevate our bad cholesterols. Those are the fats that are solid at room temperature: cheese, butter, meat, whole milk products, and lard. And then in the middle, we have polyunsaturated fatty acids. Those are the ones that come primarily from plant oils, things like pumpkin and sunflower seeds, walnuts, and oils such as corn, cottonseed, safflower, and soybean oil. Another interesting component about the fatty acids in the foods that you eat is whether they are cis or trans fatty acid formations. Perhaps you've heard of trans fats. In the trans fatty formation, as you see here in the middle, hydrogens lie on opposite sides of the carbon-carbon double bond. So you've got one hydrogen here and one on the other side. Manufacturers sometimes purposely hydrogenate oils because it increases the stability and the shelf life. So there's some very high-fat snack foods that can stay on the shelf for years at a time without ever going bad. And if you looked at the ingredient list, it might contain partially hydrogenated vegetable oils. And that is a key that that food does have trans fatty acids. From a nutrition standpoint, trans fatty acids are like saturated fatty acids in that they have the capacity to raise your bad cholesterol, your LDL levels. The cis formation is the one that occurs most regularly in fatty acids, and that's where the hydrogens are on the same side of the fatty acid chain as you see here. That causes a bend in the fatty acid, which actually makes it less shelf stable. Whenever you have foods that have fat in them, they do have the potential to go rancid. So manufacturers are interested in how can we keep the fat in the food but increase the shelf life. They do that oftentimes by adding trans fatty acids through the process of hydrogenation. Trans fatty acids tend to be in foods that we really shouldn't be eating that much of, things that have a lot of margarine, shortening, and shelf-stable baked goods. They raise our total blood cholesterol, and in a larger standpoint, aren't great for us because they increase our risk of cardiovascular disease. After the triglycerides, the second type of fats that we find much less prevalently in the diet are phospholipids. Won't go into much detail, but just know that a phospholipid has the same glycerol backbone that you would see in the triglyceride. But as opposed to having 3 fatty acids, a phospholipid just has 2 fatty acids attached to it, and then a phosphate group. And the phosphate group allows the fats and water don't usually like each other, But this allows the fats from the foods in your diet to interface with the watery environment of your internal digestive system. The last type of fats are the sterols. And sterols, you can see the word sterol contained in the word cholesterol. Sterols don't have a glycerol backbone with a bunch of things attached to them, but rather they are formed by ring structures. Some other sterols that you might have heard of include things like vitamin D, bile, and your sex hormones. An interesting thing about cholesterol is that cholesterol is only found in animal foods. So people who follow a vegan diet, means absolutely no animal foods, have no cholesterol in their diet. Now, your body still makes cholesterol, so they might have cholesterol circulating in their system, which they need to live, but they don't consume it from their diet. Occasionally, you'll see something touting, we fry our French fries, or we fry our foods in cholesterol-free peanut oil. And you, as a consumer, should not be impressed by that. A peanut is not an animal food. A peanut doesn't have a liver to synthesize cholesterol, and peanut oil never had cholesterol in it. You only get cholesterol from animal-containing foods. There's no cholesterol found in plant-based foods. I mentioned some of the sources of fat, but just as a summary, fats can come from a variety of places in our diet. A lot of people get fats from animal foods, things like meat, fish, poultry, and eggs. But you also get fats from legumes, seeds, and nuts, from dairy products and condiments, from foods even like coconuts and avocados. Those are fruits. Fruits don't generally have fat, but coconuts and avocados do. And then many people get too much fat from added fats in their diet, things like oils, butter, and margarine. How much fat do we need in our diet? Well, a good rule of thumb is that the American Heart Association and most heart health institutions recommend that 30% or less of your calories should come from fat. That's a heart-healthy diet. Now, 20 to 35% somewhere in there is fine. If you have 10% or 50% of your calories coming from fat, that's too much. We should all aim to keep our saturated fat to less than about 20 grams a day, and you really don't need any trans fat in the diet. You don't actually need saturated fats either, but we get some of them, especially if we eat animal-containing foods. So let's do one application of this to try to figure out how much fat a 64-year-old male who's just had a heart attack needs. He met with a healthcare professional who said, after your heart attack, I think you need to lose some weight, and I recommend that you go on a 2,200 calorie per day diet. The healthcare professional goes on to say, you're at especially high risk for a repeat heart attack, and I think you would benefit from a very low-fat diet, less than 20% of your calories from fat. So what I'd like you to do is to figure out what's the maximum number of fat grams per day that this guy can eat with this prescription. And the missing piece of information that you need to know is that every gram of fat has 9 calories per gram. So again, take a moment and figure out how many grams of fat per day max should he be eating to meet 20% of his calories coming from a 2,200 calorie diet. Here's the solution. The question asked you, what's the maximum number of fat grams that he needs per day? Well, 20% of his 2,200 calorie diet would be 440 calories from fat. That's good to know, but the question didn't ask how many calories from fat he needed, but rather how many grams of fat does he need. Grams of fat is what's listed on the nutrition facts panel of the different labels on foods that we eat. If you know that every gram of fat has 9 calories per gram, you can do the calculation. 440 divided by 9 gives you roughly 49 grams of fat. So this is a pretty low-fat diet, but it's important for this gentleman in his recovery phase, especially if he's trying to lose some weight, to get his fat down somewhere close to 50 grams per day. If you're interested in learning more about dietary fat, I recommend that you check out some of these websites. The Food and Agriculture Organization, the Centers for Disease Control, and the Medline Plus website from the U.S. Library of Medicine has some good information, as well as does the University of California at San Francisco's patient education handout on dietary fat.